when we started this study and the data I'm going to be covering, we knew nothing about pHs. We knew it was a pollutant. We were not particularly looking for it. We were actually much more interested in taking a more holistic approach at answering Clean Water Act goal problems, which are, frankly, a huge financial issue on the taxpaying public. Okay, I've got it working now, I see. Okay, so what I'm going to cover tonight first, I'm going to introduce the organization I work for, because I think that's pertinent to some of the material that I'm going to be covering. I'm going to talk about how we set out about examining a watershed and what we were trying to answer. I think that there should be interest above and beyond pHs and coal tar-based sediment. There should be interest in this kind of subject from all of you. You're all taxpayers or utility payers, and this is a large area of potential future expense. And I think there should be a lot more interest from the public in making sure that we get how we expend our public dollars, make sure they're being spent correctly and answering the right problem, that we're actually getting some sort of deliverable for it. And then I'm going to talk a little bit about aquatic life and how that fits into your whole permit conditions. And lastly, I'm going to go cover what we found out about pHs in our area and what we then set out to do about that. So our project area, I primarily work in DuPage County. I also work in western Cook County. These black lines represent the county lines. These red lines represent watershed area. There are three principal watersheds: the East Branch, West Branch of the DuPage River, and Salt Creek. It's about a 360 square mile area. It's highly urbanized. The urban gradient, and pay attention to this because this is relevant to our later discussion, runs from City of Chicago is over here. So the urban gradient runs this way, meaning impervious surface, as we move from, as you're looking at it, moves to the left of the diagram, impervious surface decreases. So it's about 30%, 35% in this area. As we move over to here, it gets down to about 20%. The DRSCW itself is a list of membership that you see. This originally came out of a concept dreamed up by, partially by myself, but also mainly by some wastewater operators who were a little frustrated. They didn't feel that their dollars that they were spending to improve water quality were being well spent. They felt there were a lot of things they could do that would be cheaper and more effective. And they came up with the concept that perhaps we should do an evaluation of the complete watershed, look at all the things that could possibly be done, instead of just taking what was handed to them by the lawyers from the state and federal government. And this may seem like common sense to a lot of you in the room, but this is really not the way systems generally work. There is generally a permit which is issued by the state, goes to the wastewater entity, and the wastewater entity then enforces that permit. Are those things on the permit really the best things that we could be doing? That is what we wanted to answer. And by best, I mean, will they improve the aquatic environment, and do they do that in a cost-effective way? So the watershed that we were working in, this is what we essentially faced: highly urbanized, a lot of infrastructure, a lot of stormwater inputs. You can see here, this is a classic urban feature in our watershed. These, what we call a trapezoidal channel in engineering, but these very eroded banks. I'm sure you've seen them if you visit your local river. We've got these very steep banks. That's a classic signature of stormwater inputs. Also have denuded vegetation. We've got a lot of what we call a highly fractured system, where you've got a lot of dams and culverts which break the interconnectivity of the water, meaning a fish passage, etc., is disrupted. And we also have this item here, which is very high peak storm flows because of the high impervious surfaces. Now, we're also aware that impervious surface does increase these peak storm flows, but it is also statistically correlated with a lot of pollutants that come in from those stormwater sources. Metals, volatile organic compounds, and salts from our winter de-icing operations. We did not pick any one of those to go after. We've said, let's put together enough resources that we can look at all of those things and then weigh which is the most important. Now, the way we did this was by pooling resources. We had to go around to each one of those municipal entities, each one of those wastewater treatment plants, and make a case to say, if you put a small amount of dollars forward, we can pull all of those resources and we can do an actual rigorous mathematical study based on empirical data that we will collect, and say, what are the best things that we should be working on? And perhaps we can build a better watershed management model than what we currently have. And so we've been doing this now for 10 years. Trust me, when it's a work of passion, 10 years goes in pretty quickly. Becoming a parent during that time probably has something also to do with that very quickly. But we looked at fish and macroinvertebrates. So macroinvertebrates is a fancy word for the insects in the stream. Now, this is critical, and I really want to put this across to everyone in the room. When we talk about pollution, we're often thinking about chemicals going into there. But the reason we're interested in that chemistry is because its effect on biological organisms, be them Homo sapiens, ourselves, or other biological entities. Now, you have a permit. Each one of you belongs to a municipal unit, and all of you are clients of a wastewater entity of some kind. Perhaps you're on septic, but if not, you are, unwittingly, you have a permit through a wastewater entity. The basis for those permits is what is the biological condition for the stream that that stormwater, or especially that wastewater, is being discharged to. So what the state does is they come and they look at what they call biological integrity. They measure the fish species in the stream, and by the measure I say they look at the diversity, and they look at the diversity of the insects. Now, this is hidden away at the back end of the permit process, but it's a very, very important step. Because what they're doing then is, are you supporting a sufficient amount of fish and insects? And if not, then you must be doing something wrong, and we need to fix that. Now, we're agreed on that process up until now. I think that's a fine process. But what happens then is that they list a whole series of things that could be causing that lack of fish and insects. Then it gets turned into a thing called a 303D list, where basically they're saying these are the things we can do something about. So you may start out with 30 things on that list. By the time it gets to the 303D list, which goes into your permit, there may be 1 or 2 things on there. Now, all those other things that were lost, were they important? Well, the person who did the survey thought so. We can read it, we can look at it and go, we might think so, but because they're not legally enforceable on your wastewater treatment plant, they get lost from the process. What we wanted to do was mathematically look at all of those things and say, are they more important than perhaps the things that we are doing? And so could we spend the money that we're spending doing the things that the state's attorneys are telling us to do, doing these other things and perhaps make more progress? So we were trying to approach this from a business point of view. The other thing that we did was that we measured habitat, water chemistry, and sediment chemistry. Habitat, for example, the gravels in the stream, etc. Every biologist knows that that is vitally important for supporting insect and fish populations. That never appears in anyone's permit. It just cannot be done. There's not the legal enforceable entity to do it. What we were saying was, if we find it is important, we would voluntarily take that on to do if you give us space from other requirements. Now, we measured all of these things, and I'm not going to go through. There were hundreds of different types of pollutant that we looked at. But we also did this on a very large geographical scale. We had over 120 sample sites. Each one of these little icons represents a sample site. This was one of the most rigorous watershed management data studies in the state of Illinois. It's more expansive than the one that the state does, not only in terms of the amount of sample points that we took, but also in the breadth of the water chemistry, sediment chemistry, and habitat issues that we looked at. Now, one of the things that came out of that was, in fact, that we are failing miserably to support aquatic life. Each one of these red icons represents a place where we are not meeting the state's goal for fish and insects. It looks like a lot of job security. But there's a lot of data that's hidden in here. There's a lot of variation here. This is a kind of it's not quite binary because you see 3 different colors, but largely you're passing or you're failing. But in a lot of cases, you may be close to getting there, or you might be really far away from there. And that's not really important to tonight's discussion. I just wanted to put it in there. But then we were posed with the problem, okay, what explains all of this? What, in the hundreds of data points, or hundreds of different analytes and habitat features that we've covered, what can explain all of this? Well, one of the things that we collected was sediment. We did that at over 40 sites. We couldn't afford to do it at every single site. It's one of the more expensive items that we looked at. And what we were really interested in was metals. I spent a lot of time studying water resources and water pollution. Metals is very classic in stormwater pollution. A lot of our cars release it. Our brake pads in our cars release it. So this is a lot of stormwater dollars in research are sucked up by looking at metals. So we were primarily interested in metals, but we also looked at pesticides, PCBs, semi-volatile organics, and volatile organic compounds. Now, the pHs that we're all interested in tonight are a subgroup of those semi-volatile organics. pHs that we looked at in this study were what Barbara had referred to earlier as the the US EPA 16. So these are the priority pollutants from US EPA. Some of them are very common in stormwater wash-off. And then other ones, as Barbara had mentioned, are known human carcinogens. So a couple of items, Barbara covered this a little bit, but I think I want to mention it again. We looked at a series of levels. One was present, but not of concentrations that were any concern. The second thing is that we measure is a thing called the threshold effects level. So that's an effect level, as I said here, where you're going to see impacts on the life cycles or the health of some of the more sensitive organisms. The other one is a thing called a PEL, a probable effect level, and that's where you're going to see health effects on a whole range of organisms, even pollutant-tolerant organisms. So there's two levels here, TEL and PEL. PEL is a very high level of pollution, but I just want to reflect that TEL itself is still a high level of pollution. It's just a lower threshold, but it still means that pollutants are present at levels that should be of concern. So the whole project area, you may recognize a lot of those sample points. We were looking at the diversity of fish and insects earlier on. Another way to look at this is the Salt Creek watershed. So this is metals, and this is PAHs over here. So once again, we're looking at those 16. So what this shows is that there was only really one location, and this is one of the most heavily urbanized areas that we have. It's also it's a relatively older urbanized area. In that area, there were two metals at that site. Off the 12 metals or whatever that we looked at, there were two that passed that threshold effect, or that probable effect threshold. You look at PAHs here, and see, once again, every site was above the threshold effect level, but you can see there were multiple sites where we had 3 to 5 or 6 to 7 exceedances of that probable effects level. So we started out really looking for metals, and we really come up that PAHs were the principal pollutant that was in our sediment. I put this together. It's a little confusing. I'm sure that with a bit of thought I can think of a better way to do it, but I was putting this together at 1 o'clock last night. I had an earlier presentation today on road salt application, and so I'm kind of switching gears on this. But what I just want to pay attention to, this is 2012. There's more up-to-date data. We have data all the way up to 2015. We just haven't finished our quality controlling it yet. But one of the things I want to show here was, once again, just this. These are averages per site. So, we looked at 13 metals, 6 PCBs, 22 pesticides, and 16 PAHs. On the PAHs, and this is in the west branch of the DuPage River, this is our best river. Salt Creek and East Branch are more urbanized. As you saw on the map, they had multiple sites. So this just happens to be the most recent one where we finished looking at the data. That's the reason that I'm using it. But even there, we detected 10 of those 16 PAHs. The 5 exceeded the threshold effect level, and these are averages. So at the average site, 5 were above the threshold effect level, and 2 were above the probable effect level. And at 19 sites of the 21 were exceeding the probable effects level. You can see with the metals that we originally, this 6 is in here because when you average it out, it came out as 0, which is of course ridiculous when we were saying earlier that we found 4 of them exceeding it. But when you do that averaging, it comes up as 0. That's just a kind of mathematical outcome. But you can see once again just the number of sites and the number of metals that were present. It just really puts into the scale that pHs that we did not even see on the horizon were actually a much larger problem than metals. So at this point, we had to work out what we were going to do about this. Should we do anything? What was available to us? First of all, what kind of problem were they? So we did a lot of research where we looked at, okay, if pHs are a problem, what kind of thing would we do about it? We're stormwater engineers, etc. Surely we can come up with something. Well, it turns out there really wasn't very much that we could do. pHs behave a lot when they enter the environment. They behave a lot like suspended solids, and in fact, they adhere to the smallest sizes. We measure these in microns, millions of a millimeter. They adhere to the very smallest set of suspended solids, and that's a problem because those are suspended in solution longer. They're harder for us to filter out. So this is the hardest. They're concentrated in the hardest group of solids for us to contain in any of our operations, any of the filters that we would use, any of the settling ponds that we would use. Other things that we looked at potentially was things like street sweeping, and that kind of activity, none of those really looked cost effective or were going to be done in any kind of frequency or policy that really looked like something that we could say this is a way for us to control PAHs. So the other thing was noticed, of course, that we did note that there was a lot of research out there, and I actually, Barbara was showing some additional research that they carried out, but there was already a lot of data out there saying that pHs in sediment did have toxic effects on aquatic organisms. And at this point then, this is when we started to find that there was research out there that was suggesting that there was a newly identified source of pHs in urban sediments, which was refined coal tar sealant. So we started analyzing and we started looking at the pros and cons. How prevalent was that in our communities? The general evidence was that it was there was a lot of usage in our communities, and that once again we could see there was a lot of reports coming out, not just from USGS but from several other entities that was supporting that this, in fact, that the pHs coming from coal tar sealant were both toxic to organisms, and in fact were that coal tar itself, in fact, maybe was not just another source, it was perhaps the principal source in a number of Midwestern urban areas. I'd like to mention at this point is that we did invite several experts to talk to us. First one was Dr. Allison Watts from the University of New Hampshire. We also had Dr. Judy Crane from Minnesota Pollution Control Agency, and Peter Van Meter, who Barbara had mentioned earlier, also was invited to talk to us about this. Now, the reason I'm mentioning them here is they very generously, some of these researchers, when we contacted them, were very surprised that we were interested in their research at all. I was kind of going, would you mind taking a few hours to run us through your research? And they were like, really? Okay. So I want to say thank you on their part for lending their expertise to this. I'm going to quickly just go through some of these studies that we talked about. So this study in New Hampshire was done, and I believe it was actually done in collaboration with the Pavement Coating Council. They took some of their parking areas at their college. They put some of it under, they sealed some of it using RT12, and the rest of it they left unsealed, and then they measured the loadings from those, from runoff in that. In fact, I think the next slide just sort of brings this home, was that this is from the sealed areas where you were getting 1,000 milligrams per kilogram. From the unsealed areas, we were getting less than 5 milligrams per kilogram of total PAHs. Once again, goes to the orders of magnitude of difference of pH loading between, the difference between an unsealed parking lot and a sealed parking lot is not minuscule. So the other item then was that we also were particularly interested in this study because one of the things that we were worried about was pHs at these concentrations, if they're ending up in sediment in our rivers, what is the sediment in our detention ponds? And a lot of you are familiar, we use detention ponds here to cut peak storm flow from impervious surfaces. This is cut down on flooding. But a lot of that material is ending up, it settles out in these basins, and at some point those basins need to be dredged in order to maintain capacity. What would the concentrations look like in these ponds? So this study was done in the, I guess I'm going to go to the, this study was done in the St. Paul, Minneapolis area. Their findings were that in those detention ponds, they looked at, I believe it was 20 detention ponds, that over 50% of the total PAHs in those detention ponds were from refined coal tar sealant. And if you let me finish, I've only got a couple more slides. And just so we can keep all the questions in a group. Their conclusion, once again, was that, so what we did at that point then was that we looking at the relative concentrations in pHs in asphalt-based sealants relative to coal tar-based sealants. We worked with a couple of vendors who produced both asphalt-based sealants and coal tar-based sealants. We did a cost-benefit analysis on what were the application costs. Despite the fact that I would tell you I'm an unabashed tree hugger, I'm also a capitalist, and I believe in looking at the cost-benefit of all of these things. It's something I want to make sure our members said we want to have a better environmental product, but we want to make sure that we're doing it for as cheap a price as we can. We could not find a significant cost difference between the two items. I know that there is debate about the pros and cons of each one of those sealants. The products that we worked with, the vendors said that they stood equally behind both products in terms of the performance. So on that basis, we are not a regulatory group. We do some work with our permits on our clients, their stormwater permits and their wastewater permits, but it's a voluntary. We said to our members, we think that this product is harmful to the watershed, we think this product is harmful to your facility because of your detention, so that might be an even more immediate issue, and that we ran you through, they all attended these presentations, we presented the cost-benefit data to them, and we said that if you voluntarily want to stop using it, at the public works level, you can sign a memorandum of understanding with our organization, and a number of organizations have done that, including DuPage County itself, which was the largest entity that took this on.